Today's lesson is about the trig graphs of cosecant and secant. You should remember that cosecant is the same as 1 over sine. So that's the first one, and we'll label the y-axis cosecant of theta. We remember that sine is y, so that's like saying 1 over y. And if I do that, I should remember that y cannot equal 0. Anywhere that it does equal 0 then is an asymptote. So, get that dead on. Okay, I'm going to go ahead and label my x-axis, which is my theta axis. And I'm going to go by pi over 2. So I'm going to do pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. In the other direction, I'm going to say negative pi over 2 and negative pi. We have noticed that our points of interest are 1 and negative 1 in our original. That is true here as well. And then we're going to use our unit circle to begin to construct this thing. So starting with pi over 2, we're going to start there. If I go from 0 to pi over 2 on my unit circle, my y value, again we're doing cosecant, which relates to sine, so we're looking at y values. The y value is 1. If I do 1 over 1, that's 1. So at pi over 2, I'm going to put a mark at 1. If I go back to 0, I will notice that I have 1 over 0, which is undefined. So again, there's another vertical asymptote here on top of my y-axis. Okay, now if I go halfway in between 0 and pi over 2, I'd be at pi over 4. Pi over 4's y value is root 2 over 2. So if I do 1 over root 2 over 2, and I do all of my reducing and my simplifying, that's the same as saying the square root of 2. If I convert that to a decimal, it's about 1.4. So at pi over 4, I have about 1.4. If I go to my value in between pi over 2 and pi, that'd be 3 pi over 4 on my unit circle, which is also root 2, or 1.4, which is like so. Then, if I look at more values, or if I just kind of estimate here, I've got what I call an upward scoop. That's my lowest point, or my minimum, and the other two lines are going to hug those two asymptotes. They go on and on and on to infinity. If I go to 3 pi over 2 on my unit circle, my y value is negative 1. If I do 1 over negative 1, that'd be negative 1. So here, the value is at negative 1. Similarly, if I look between pi and 3 pi over 2, I'm looking at 5 pi over 4, which is negative root 2 over 2. If I take the cosecant, or 1 over y of that, it's negative 1.4. Same thing for 7 pi over 4, which creates a downward scoop in the second group. Now, if I continue that pattern, making sure my minimum for the bottom scoop and my maximum for the top scoop is 1 and negative 1 respectively, that's what my parent function of cosecant looks like. You will notice that it takes 2 pi to complete one period for that cycle to start over. So that's my period. My amplitude does not apply in this case because amplitude, remember, is a distance from the midline to the top or the midline to the bottom. These are going to infinity and negative infinity, so there really isn't a midline there. The next thing we want to look at is the domain. That's all the way across my x values. In this case, it'll be easier to say what x cannot equal, and that's my asymptotes, which would be like negative pi, 0, pi, 2 pi, 3 pi, on and on and on. My range, if I look at my y values coming from bottom to top, I go from negative infinity to negative 1. Notice there's a bracket on the negative 1 because it really does touch that point. And then from 1 to infinity. The other thing that I should point out here with my pencil is to show you that you should remember we're talking about sine and cosecant having a relationship, and that one is the flip of the other. If I drew in my sine graph really lightly here, and hopefully you're getting more and more comfortable with what sine looks like, that's that very light line that I've done here. And you will notice when it touches 0, that's where the asymptotes are, that's undefined. But this scoop is the flip of that one, and this scoop is the flip of that one. And so that should kind of make sense to you there. Okay, that's it for the graph of cosecant. The graph of secant is very similar. So let's go ahead and label our axes. We're going to do pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, on and on and on. Negative pi over 2 and negative pi. We want to label 1 and negative 1. And now let's go ahead and look at our values. If I start at 0, remember that secant is the opposite of cosine, or 1 over x. My x value here is 1. 1 over 1 is 1. So that's up at 1 on my y-axis. Okay, now around that, I could go to negative pi over 4 and pi over 4. If I go to negative pi over 4, the x value is root 2 over 2, which we know is 1.4. If I go to pi over 4, my x value is root 2 over 2, which is also 1.4. And so if I draw my scoop, that one is facing that direction. It should make sense to you then that when I get to pi, let's see if I get that in focus right here, pi 1 over negative 1, at pi, my value is negative 1. And halfway between, I'm getting that bottom scoop. And that pattern will continue again. On and on and on. And my scoops go up and down respectively, just like the top one did. The period is still 2 pi. The amplitude does not apply. The domain, the x values we want to kick out, are things like negative pi over 2, 3 pi over 2, any of the pi over 2's. The range is from negative infinity to negative 1, and from 1 to infinity, just like above. On the flip side, we want to look at the transformations of this, so let's go ahead and take a look there. And that is y equals a cosecant of b times x minus c plus d. Hopefully you're noticing that that never changes, that general formula. We reviewed that the a changes the amplitude, the b changes the period, the c shifts left or right, and the d shifts up or down. To find the new period for both secant and cosecant, I'm going to do 2 pi over b. And that should make sense to you because these relate to sine and cosine. Their period is 2 pi, so we take 2 pi divided by b to find the new one. We're going to look at 2 examples. Number 1, if y equals negative cosecant of x, or negative cosecant of theta. Either way is fine there. Okay, what's happening is I've got a negative, so it's reflected or flipped. I'm going to go ahead and draw my x and y axis here. Label, I'm just going to go by pi over 2. For now, I'm just going to go 2 pi. I don't have any amplitude change, I don't have any period change or shifting left, right, up, or down. So the general formula is probably a pretty good place to start. If I look at my original cosecant graph back on the front side, that was the one that had asymptotes at 0, pi, 2 pi, and all of its intervals. So we're going to go ahead and do that. Draw in our asymptotes. Those intervals. My normal cosecant graph starts with a scoop up and then a scoop down. Since this is flipped, I'm going to start with a scoop down and then a scoop up. And I did tell you that you only had to show me one period. However, you could continue if you wanted to and go on and on and on. That would be one period of that graph. The second example that I showed you in class was y equals 3 secant of 2x plus 1. Several more transformations going on here. The 3 is telling me that my amplitude changes to 3. Remember, amplitude we use lightly here. That just gives me my max and min for my scoops. 2x tells me that b is 2, so if I go out to the side and do 2 pi divided by 2, that will give me my new period, which is pi. And the 1 tells me that I move up 1. Now, if my new period is pi, I need to take that into consideration. Let's go back and look at the original secant graph. Its period is normally 2 pi. Ours has now been cut in half. So it's pi, which means half the scoop is happening in pi over 2, and the other one is happening in another pi over 2. Notice in secant that it is cutting the center. It's cutting the origin here, the y-axis. So what's going to happen in pi over 2 for us has to be cut in half. Half of pi over 2 is pi over 4. So when I draw my x-axis, my y-axis, I'm going to want to go in pi over 4. So negative pi over 4, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, on and on and on. I'm just going in increments of pi over 4. I want to have 3 on there for sure, and negative 3, because that was my new amplitude of sorts. I want to shift up, so now I'm at negative 2 and at 4, which is my high point, my low point. 1 would be my midpoint. Remember I told you yesterday that we talked that sometimes I'll put a star there just to kind of reference for myself where I'm starting. Then I want to put in my asymptotes, which are at the beginning middle and end. The beginning is shifted over just by a little bit, and so that's at this negative pi over 4. And it is splitting the distance here. It goes to 3 pi over 4. From negative pi over 4 to 3 pi over 4 is indeed an entire pi, which is our new period. We know that it's shifted up 1 and its amplitude is 3, so the top scoop will start at 4. And the bottom scoop then will start at negative 2. And we will continue from there. That's one period, so that's all we would really have to show. Okay, your assignment for this is A8, and it's page 339, numbers 12, 14, 16, and 18. Good luck, and let me know if you have questions.